Thank you, everyone. The learning is taking place on the Promethean board. Today we are going to use an area model, a digital interactive area model, to represent unit fractions. Say unit fractions.
Unit fractions.
Okay. The area of the square represents one whole. What does it represent?
One whole.
It could be one whole pizza, one whole chocolate bar. There's a lot of real world connections we can make. Now, raise your hand. Here's my question. Please don't shout out. What area, what fraction is shaded? What fraction is shaded? Or what fraction is represented? Okay, whisper in your partner's ear. Ready, go.
What's the unit fraction?
Thank you.
What's the unit
Samuel, what? Oh, hold on. My bad. Okay, what did you tell your partner first? Samuel, what did you say?
I said
1 out of 2. Do I have 1 out of 2 yet? No, I made a mistake. Here's what I should have done. Okay, now, because your answer should have been miscellaneous. There's nothing shaded. Okay, now think about it and don't shout out. Whisper to your partner, what fraction is shaded? Go ahead. Look at the equal parts. All right, Samuel, what did your partner whisper to you? One out of how many equal pieces are in our chocolate bar? Yeah, good job. All right. Okay, so the fraction that is shaded is 1/4. Thank you. Okay, now, this is fun. Don't shout out. Why don't you just think for like 5 seconds, what did I just do? What just happened? Okay, now, you guys are so excited to learn, aren't you? Okay, put your hands out real quick. Because I'm just going to call on someone random this time. Okay, here's the question. What fraction equivalent to 1/4 do you see shaded? What fraction equivalent to 1/4 do you see shaded? All right, Sergio, talk to me.
I got 3/12.
Tell me more.
Because I saw the blue, it was shaded 3 times, and then you added the lines, so I counted the blue, so I got 3, and then I counted all of them.
Very good. And when I added the lines, did I add them or was I like cutting them up?
Cutting them up.
And friends, do you remember that vocabulary word for cutting up? Slice, decomposing. It starts with a P.
Partition.
Partition. Everyone say partition.
Partition.
All right, so I had fourths, partition. And then I partitioned going this way. How many times did I cut, slice, partition?
4.
I partitioned twice so that I would have how many equal parts are now in my whole? 12. Okay, so I can say 3/12, 12 equal pieces in my whole is equivalent to what fraction did I have prior to when I partitioned? Yes, ma'am.
1/4.
1/4. You want to stop it? Friends, point to where the learning is taking place. The learning is on the Promethean board. Okay, watch very closely. Don't shout out because we don't steal others' learning.
You take your water with you.
What fraction is shaded? Oh my gosh, do we all know? Okay, tell me, everyone.
2 4s.
2 4s or 2, Samuel, we have 2 pieces shaded out of 4 equal pieces in the whole. Okay, what does my book say to ask next? Okay, we did that. All right, are you ready?
Yes.
Remember before when we went like this with our hands?
Yeah.
What was the vocabulary word that we were acting out?
Partition.
Partition. Okay, I'm gonna partition. Are you ready?
Yeah.
Okay. Here's your next question. What fraction equivalent to 2 fourths do you see shaded? I love the excitement in this room. Thank you for paying attention, focusing. I want you to think about your math vocabulary that you're going to use to answer this question. Adrian, you thinking? Are you thinking? Okay, Emma, I saw your hand in the air. What were you about to say?
I was gonna say, you partitioned it into 6 twelfths.
I partitioned it into 6 twelfths. How about let's say this? I partitioned it into 12ths. Because prior to this, I had what, Emma?
6.
I had fourths. Now, when you said 6 twelfths, the 6 was the numerator or denominator? Numerator. Good job, you guys. So I actually partitioned it. I cut it twice to have 12 equal parts in my whole, 4, 8, 12. But then, Emma, what does the 6 represent as far as, what does the 6 represent? You told me it was the numerator. Is there another way we could explain that?
The 6 represents the parts shaded in blue.
Very good. So the answer to this question is 6 twelfths of the whole are shaded. Now, 6 twelfths, say equivalent.
Equivalent.
Is equivalent to, what did we have right before I partitioned it?
2 fourths.
I had 2 fourths. Good job. Okay, now I'm gonna veer off really quickly. I see 2 as the numerator, and then 6 became the numerator. I see 4 as the denominator, and then 12 became the denominator. How are those related? Talk to the person sitting.
Because they just tripled the 4 for the 12. And that 12 is also, and 6 is a multiple of 2, and 12 is a multiple of 4.
All right, thumbs up when you're ready. There were so many beautiful conversations being had. Kalandra, talk to me about what you said.
I said that they're all equal to 2 because it'll be 2, 4, 6, and then the 8 will be left out, and then it'll be 12.
Okay, so you were considering this 2 in the numerator? Yeah. And then you skip counting by 2s?
Mm-hmm.
How many times did you skip count by 2s?
4. Oh, 3.
3. So could I say 2 times 3 will get you to a numerator of 6?
Yeah.
Yes.
Okay. Who can add on to what Kalandra said?
They're all multiples of 2.
Agree or disagree? So, okay. Now, what I do to the top, I also do to the bottom, right? So if I multiply 2 by 3,
4 times.
I would do
4 times
4 times 3. Now, you are right. Well, first of all, what is 4 groups of 3? 4 times 3? 12. So when you multiply the top by a factor of 3 and you multiply the bottom by a factor of 3, you know you'll get an equivalent fraction every single time if you're multiplying the top and bottom by the same number. Now back to the multiples of 2. Really like that. Kind of veering off a script here. But if you skip count by 2s, are you going to hit 6? Yeah, if you skip count by 2s, are you going to hit 12? Absolutely. Okay, so we talked about a few important words. We talked about partition, decomposing, slicing. How about denominator, and equivalent fractions. All right, give me an air high five. 1, 2, 3.